Good afternoon. Thank you for joining us. I'm Robert Baylor, Director of Communications at NUCA. Welcome to our latest Webinar Wednesday. December's Webinar Wednesday is about the important concept of the adjacent area next to a job site excavation. In the world of excavation safety, the adjacent area refers to the area out from the lip of the excavation that is equal to the depth of the excavation, and that area is sacred. It doesn't mean workers can't put anything there or can't work in that area. It just means everyone needs to respect that area and observe some very real limitations and safety concerns. The OSHA Excavation Standard also has specific requirements that address this important subject. Some of these requirements relate to protective systems, and others involve job site safety principles and management. National Trench Safety's John Preston is here today on Webinar Wednesday to address the safety concerns of the adjacent area. He's well versed on this subject and brings to this presentation over 25 years of experience in the excavation safety industry. He has held positions as Director of Training and Director of Safety and is currently serving as a Senior Safety Trainer for National Trench Safety. John is also an OSHA Outreach Instructor, teaching the OSHA 3015 course, and holds a master's degree in Training and Development. Thanks so much for joining us today, John. I turn the webinar over to you.
Thanks so much. Hello again, everyone. I'm John Preston. Thank you for joining us today. This is a very important topic, one that could actually save a life. And as I was thinking about this morning, I was thinking about something that a friend of mine told me after he took the Smith Safe Driving program. One takeaway for him was the concept that when you're waiting at a red light, don't immediately enter the intersection when the light turns green. Somebody might be running the red light. And that's exactly what happened to my friend on one day. When the light turned green, he hesitated before entering the intersection, but a car in another lane did not. And the car that went into the intersection was struck by a vehicle running the red light. That one important concept made a difference for him that day. This can be a good safety topic for a tailgate safety meeting. We could share this concept with people on the job site, and it could save a life. Now, the adjacent area of an excavation is defined in a part of the excavation standard that does not get a lot of attention, Appendix C, which covers timber shoring. So let's first look at the anatomy of a trench. At the top of a trench, we have the edge or the lip, and at the bottom, we have the toe. And then, of course, we have the face or sides of a trench. The definition of the adjacent area, as given in Appendix C, is the area out from the trench that's equal to the depth. So in our example, we have an 8-foot trench, and the adjacent area would be the area that extends out on each side 8 feet. The adjacent area also covers the underground area below that adjacent area. Now, there are two instances where the adjacent area is significant. One has to do with protective systems, and the other has to do with adjacent structures. We're going to look at each of these. Let's start with protective systems. It all begins with the gravitational forces that are there. When we dig a trench, those gravitational forces become what we call cave-in forces. In other words, the downward pressure also has lateral pressure, and that is why all excavations walls will eventually collapse. And we have to make sure that there's no misunderstanding about this. All trenches, all excavations will collapse if they are not protected from cave-ins. We do not know when the walls will cave in, but we do know that these lateral forces will cause a cave-in. The simple reason is because the weight of the soil is greater than the strength of the soil, and these lateral forces will cause a cave-in. Now, shoring systems are designed to support the sides of the trench to prevent a cave-in. Shoring systems will put pressure into the walls of the trench, into the sides, And as long as the shoring systems are placed correctly vertically as well as horizontally, then we can prevent a cave-in. All shoring systems have to be adequate. Now, any surcharge load that we have in the adjacent area will increase the downward pressure, and of course that's going to add lateral pressure, and that is going to be pushing against our shoring system. What we have to do is limit the surcharge loads within the adjacent area so we do not overwhelm the shoring system. So the question, of course, is what are the load limits within the adjacent area? Now, I would like to start by taking an example from Appendix C of Subpart P, timber shoring, because that is where the concept of the adjacent area is defined. Appendix C has tables that provide the size and spacing of the wood shoring members. The tables are set up for different soil types, soil type A, type B, and type C. Now, the deeper that we excavate and the worse the soil type is, the greater the pressure is going to be on the shoring system. And so these tables provide us with some idea of how large these shoring members have to be and how closely spaced they need to be in order to provide the strength so that they can prevent a cave-in. Appendix C defines the adjacent area, and it gives us the load limits that we are allowed to place within the adjacent area so that our wood shoring system will be adequate. So let's look at the three timber shoring components. We have uprights, and these are planks or boards that are placed against the sides of the trench. Then we have wales, which are structural members that run horizontally down the trench, and these bear against the uprights. And then we have cross braces that are going to support those wales. These three components, uprights, wales, and cross braces, are going to form the wood shoring system, and the size and spacing requirements are essential so that we can prevent a cave-in. Now, when we are using a timber shoring system like this, using OSHA's Appendix C, we have to observe the limitations for surcharge loads. In the adjacent area, we are only allowed up to 20,000 pounds for equipment or materials, and we're only allowed a 2-foot high soil surcharge in the adjacent area. Any more surcharge load than this, we cannot be sure that our protective system will be adequate. What about other protective systems? What about aluminum hydraulic shoring or shields? Well, they have surcharge load limits as well. We need to know what those surcharge load limits are. We can get that information from either manufacturer's tabulated data, or we could get it from the manufacturer. I have seen manufacturer's tab data that limits the surcharge load for a shoring system or a shield system, as you see on your screen, 36,000 pounds for materials or equipment, or a 3-foot high spoil pile. Now, again, we have to check with the manufacturer or manufacturer's tabulated data to see what their specifications are. One thing I'd like to point out, though, and that is just because we have a load limit within the adjacent area, it doesn't mean that we can ignore any surcharge loads beyond the adjacent area. In other words, we have to use some common sense. We can't just say, well, I know that's a 100-ton crane that's just outside of the adjacent area, but I don't have to worry because it's not in the adjacent area. I mean, we really have to use some common sense. So while we're talking about adjacent area issues today, just keep in mind that even surcharge loads of great magnitude outside of the adjacent area, still those things still have to be addressed. And those kind of issues are best dealt with by an engineer. Now let's turn our attention to adjacent area structures. Now we're going to be getting the guidance from the general requirements in the OSHA Excavation Standard. In 1926, 651, paragraph A, it addresses surface encumbrances. It says all surface encumbrances must be supported or removed to safeguard employees. What is a surface encumbrance? In the Federal Register, OSHA explains that the surface encumbrances are items such as trees or boulders, anything that could become unstable by the excavation operation. They could be undermined or otherwise unsupported, and they could fall into the excavation. Now, there's another aspect to this. In addition to need to support or remove these surface encumbrances, there's another aspect, and that has to do with surface encumbrances can also create a blind spot. And this could be a recipe for an accident, especially in the early morning hours or the late afternoon hours when it starts getting dark. Equipment going one way around a blind spot could be met by personnel or vehicles coming the other way. And so in those areas where we have a blind spot, we have to pay attention to that. So in this situation, a surface encumbrance is not necessarily a physical thing that could fall in the trench, but it could also be something that creates a blind spot or a safety hazard in that way. Utility poles. What do we do about utility poles? Well, if they are in the adjacent area, they must be secured. They must be supported. It's a lot different when you're excavating and the utility pole is outside of the adjacent area. Continuing in the general requirements, in 1926, 651, paragraph I, it states, excavation below the level of the base or footing of any foundation or retaining wall that could be reasonably expected to pose a hazard to employees shall not be permitted except when a support system, like shoring, is provided or if a registered professional engineer has determined it is safe. So they're focusing here on the base or footing of a foundation or a retaining wall. It may not be obvious to everybody that when you dig next to a wall that has a base, that we are creating a situation where that wall is unstable. Someone may only think in terms of the downward pressure that that wall has and not think about any lateral movement. A friend of mine took this picture and was unable to convince the workers that this is an unsafe situation. Again, unless someone understands how that downward pressure translates to lateral pressure, someone might miss the significance of this. And on another day, this is what happened to that wall. Fortunately, in this situation, there were no injuries, no one was hurt, but it is scary to think that someone could have this kind of misconception. Continuing in the general requirements, note the wording in 1926, 651, paragraph I, number 1, where it says, the stability of adjoining buildings walls, or other structures is endangered by excavation operations, support systems such as shoring, bracing, or underpinning shall be provided to ensure the stability of such structures for the protection of employees. So here they're talking about buildings, walls, or other structures. Further down in the same paragraph, it says, sidewalks, pavements, and appurtenant structures shall not be undermined unless a support system or another method of protection is provided to protect employees from the possible collapse of such structures. I'm reminded of a fatality incident that happened several years ago when an employee was struck by a section of sidewalk that fell in. The trench was only 3 feet deep. But you know how heavy a section of sidewalk can be. So this is an example of how even in a shallow trench, we have to support any of these type of things that might be in the adjacent area, which could move into our trench. Shoring in these shallow trenches is a good way to make sure that people are safe from these structures. I pulled an OSHA fatality story off the OSHA website. It says at 2:59 p.m. on December 17th, 2019, employees number 1 and number 2, employed by a construction company, were working inside a 32-inch deep trench and using shovels to dig under a concrete foundation slab/wall at a residential structure. The concrete slab, which measured 8-inch thick by 12-foot long by 24-foot wide, became dislodged from the surrounding soil and collapsed onto the 2 employees. Employee number 1 was pinned between the concrete slab and the trench's opposite dirt wall. Employee number 2 was pinned face down between the concrete slab and the ground. Emergency services arrived, determined that employee number 2 had no pulse, and resuscitated him. Both the employees were transported to the hospital and admitted. Employee number 1 was treated for multiple fractured ribs and other injuries. Employee number 2 died at the hospital from crushing injuries on December 22nd. It will be 5 days later. Interesting story, sad story. One of the things that stands out to me was that this was a 32-inch deep trench. So they were digging under a concrete foundation, and a large section of it became dislodged and struck the employees. I found the same story in a newspaper report, and we get some additional information. 2 construction workers were rushed to the hospital Tuesday afternoon after a shallow trench collapsed and trapped the men under a slab of concrete. The contractor in charge of the work site, where the men were in the process of building a 2-story addition to a home in the 5300 block of North Tyrone Avenue, said it happened in a split second. It was a very poor built foundation, said one person. Whoever built that a while back didn't put any rebar on it. So what happened is a chunk of concrete just kind of fell on top of the guys. Again, this is a very sad story. It is just a reminder about what OSHA is addressing when they talk about these adjacent structures. We have to have support. We cannot trust that there's adequate rebar. We can't trust that something is built correctly, or we can't trust in the example I gave earlier about the sidewalk, we can't trust that the sidewalk will stay exactly where we want it to stay. So even in these shallow trenches, this is a reminder that we need to provide a support system of some kind, an adequate support system to support the structures that are in the adjacent area. Some of the type of structures that we may not be concerned about might be smaller structures, such as a sign base. Now, these can be very deceptive because even a small sign base is going to have a footing on it of some type. And that can turn out to be quite a bit of weight. And if that is in the adjacent area, we have to be sure and support that area to keep that sign base from moving into our trench, regardless of how deep the trench is. Even shallow trenches can be very dangerous with these situations. I received a phone call one day from a gentleman who said he was digging a trench near a building, and he wanted to know if he needed to be worried about that building. So my question was, how deep is the trench and how far away is the building? And so he sent a drawing that looks something like what you have on your screen. And I did some quick math, and it was obvious that the building was in the adjacent area. So I told him what he needed to do was contact an engineer. And of course, there's two concerns. One is the stability of that existing building, but another is for the safety of any employees who are going to be inside the trench. Now, before we leave this topic, we can't forget that parallel utilities also could present a hazard. An old trench that is parallel to a new trench, if it is inside of the adjacent area, we have to make sure that our excavating operations does not allow any movement. We do not want that old trench to move into the new space. You may have heard of these horror stories where someone digs a trench parallel to an existing water line, and a cave-in traps one or two people, and the water line opens up. And of course, we know how much water can quickly fill a trench with that kind of water pressure. And so whenever we're digging parallel to an existing utility, whether it's water or gas, we need to provide positive pressure against that existing utility to make sure that it doesn't move. Moving on through the general requirements, we come to paragraph K, which covers inspections. Note that in the inspections that the competent person has to do, it specifically includes the adjacent area. Paragraph K reads like this: daily inspections of the excavation, the adjacent areas, and protective systems shall be made by a competent person for evidence of a situation that could result in possible cave-ins, indication of failure of protective systems, hazardous atmospheres, or other hazardous conditions. An inspection shall be conducted by the competent person prior to the start of work and as needed throughout the shift. Inspection shall also be made after every rainstorm or other hazard increasing occurrence. So this is directing us to do inspections of the excavation and the adjacent area as well. At this time, we would like to open the discussion up for any comments or questions that you have. Robert, do we have any questions?
Let me go. That was fascinating. Wow. I've learned a ton. I've never been in the ground yet. Let me go to the chat. We've got one.
Robert.
We have one. It is, when I'm sloping a trench, do I still need to be concerned about surcharge loads like I would if I was shoring or shielding?
Okay, that's a very good question, and OSHA does address that. When we are sloping or benching using OSHA's Appendix B, there are some notes that actually direct us to the general requirements, and it specifically states. Now, I don't have this section of the standard in front of me right now, but it directs the competent person to reduce the slope. That would be slope at a less steep angle than you would normally, and they direct the competent person to the part of the standard that we just covered today in paragraph, I believe it's paragraph I, where it talks about adjacent structures. So I would refer folks to those notes in Appendix B, sloping and benching. I would refer them to those notes, and also to the comments that are made in paragraph I of 1926-651 general requirements. Thank you. Is there another question?
Let me see. We have people wanting to either use the chat feature, or at this point, if you'd like, you can always just unmute yourself, state your name, and ask your question. We have one saying, I missed what you said about the building in the adjacent area.
Okay, let me go back to that slide. Okay, I was, thank you very much for asking for that clarification. I was referring to an incident where a gentleman called me because there was a building and he was going to be digging a trench in the vicinity of the building. And his concern was, does he need to be worried about that building when he digs that trench? And so my concern was the building in the adjacent area? If it's not in the adjacent area, I'm not going to be nearly as concerned. So I asked him how deep the trench was and how close the building was. And he sent me a drawing that looks similar to what's on the screen. And because the building is, in fact, within the adjacent area, I suggested that he contact an engineer to determine how best to deal with that building. The engineer might suggest a special shoring system, or an engineer might say it's unaffected, it's not a problem. But at any rate, the competent person would have to make sure that employees are protected from cave-ins. And of course, that protection starts at 5 feet or deeper. 5 feet or deeper, we have to have an adequate protective system. Now, this is the federal rule. Some states have the 4-foot rule. But also, we have to have a protective system if it's less than 5 feet deep, and if there is potential that someone could be hurt by a cave-in. I hope that's helpful.
John, we have another question. How do you know how to shore up adjacent structures if you're not using an engineer?
Shoring adjacent structures. First of all, if it's a common structure, and I'm just going to give some examples. For example, a sidewalk, a road, a sign-based utility pole. If we're going to shore that, we can use standard aluminum hydraulic shoring, whaler shoring. We could use vertical shores. We could use excavation braces. There's lots of products that are out there, and off the shelf, they will handle the job. They will be able to do that. Now, if it is a large, if it's a building, if it's a crane, if it's a large structure, then that's going to be left up to the engineers. I hope that's helpful. Maybe you could respond if you have want more specifics.
All right, thank you, John. We have another one as well, too. Would it depend upon how much of the adjacent structure is in the adjacent area?
Wow, that's a good question. That's tricky. I'm just sort of a by the book guy, and I think if any aspect of a structure is in the adjacent area, I'm going to be concerned. And there's a reason for my thinking. Let me just say it this way. The adjacent area is really designed, that concept is designed for most of the soils that we're going to encounter, an average soil. So in worse soils, the adjacent area is going to extend further out. In better soils, it's going to be closer in a little bit. So we're using the adjacent area as an average. So to me, anything that's even close to the adjacent area, I'm going to want to address.
We have another question. Thank you all for your interest. This is wonderful. I've heard it called an area of repose. Is that a proper term?
Oh, actually, there is a concept called the angle of repose, but that has to do with the former way that we would determine slope angles. The adjacent area is also referred to as the area of influence. Maybe the person is thinking about those two things. The area of influence and the adjacent area are the same thing. But the angle of repose is a term that used to be used, and when they revised the standard in 1989, they stopped using angle of repose and they began to use, they started using the maximum allowable slope as the concept of how steep the slope should be.
We have another question. As an engineer, I have used aluminum hydraulic shores as a support for existing buildings in multiple designs. Actual site conditions and distance away, amount of surcharge are all that needed to be evaluated. Your thoughts? I can read it again if you like.
I would say thank you for your comment, and I yield to the engineer.
Are there any other more excellent questions?
I would invite the engineer to fix anything that I might have implied that wouldn't be in alignment with the way they see things. I would invite their comments.
Are there any other questions at this time? Oh, we do have one. Thank you. Thank you for really thinking about it. I'm really finding this fascinating. Spoil piles at least 2 feet away from excavation is what you demonstrated. Were you saying there is a limit on the height of that pile?
Okay, thank you. Great clarification. Okay, the spoil pile and any tools or materials or equipment need to be kept 2 feet away, but that's for roll-off protection. That's just keeping things from falling into the trench. The height, the spoil pile height is really what I was trying to address a while ago. The height of the spoil pile determines the weight of the spoil pile, which of course is the surcharge load. So yes, it needs to be at least 2 feet away. The height of it is going to be determined by the protective system that we use. In OSHA's Appendix C for timber shoring, they limit the spoil pile height to 2 feet. Some manufacturers may allow 3 feet for the height of their spoil pile. But the 2-foot rule for roll-off protection is pretty much standard throughout the industry. Some companies are, I've seen companies that will require the spoil pile to be kept back 3 feet or 4 feet just for added safety precautions. So those are two different issues, but I really appreciate that clarification.
Are there any other questions at this time? John, I think that's it. Thank you. I learned a lot. I need to know this as well, too, even though I'm not in the trenches. When I'm trying to find illustrations to show the trenches and articles and on the magazines, I have to also follow the same safety rules as well, too, because I don't want to illustrate anything that's unsafe. So I found this absolutely fascinating for my own self.
Thank you very much, and thank you for inviting NTS to be a part of this today. I have enjoyed it, and I really appreciate everybody who signed up and joined us, and I thank you for your questions.
And John, thank you very much for your time today to present this information to our guests. I also want to thank National Trench Safety for their kind support of NUCA and our educational webinar series. Some people asked, today's webinar is being recorded, and a copy of the recording will be provided to all registrants and attendees. A recording of this webinar will also be made available on the NUCA.com website and on our YouTube channel over the next few days. And thank you for your time today to join us for Webinar Wednesday and supporting NUCA. Our next NUCA Webinar Wednesday will be held on January 6th, 2021, sponsored by another national partner. We couldn't provide our membership services without their very kind help. Thank you for your time this afternoon, and please enjoy the rest of your week.